bonjour Alex.
Bonjour, hello.
Bon, vous pouvez peut-être partager votre présentation sur l'écran.
Patrice, peut-être indiquer à Alex qui sont les membres du comité et pourquoi il y a autant de personnes en mute.
Oui, alors aujourd'hui les membres du comité sont les suivants. Donc nous avons Sophie Cluet de Sorbonne, de Bonne Université, Nicolas Landrin de l'ESSEC, Laurent Cotte, ex-IT Translation, Nicolas Pellet, Sophie Mac Innovation, et puis Sophie Pellat et Hervé Lebray du Startup Studio. Voilà.
Et les personnes qui sont...
Et l'ensemble des CPPI, donc les personnes qui accompagnent les projets de start-up sont en background, sont là pour écouter les exposés et apprendre de qui se dit. Voilà, donc c'est à vous pour 10 minutes.
Oui, d'accord.
Alex.
Okay. Are you seeing my screen?
Yes.
Okay. Thank you. So, good morning. My name is Alex, and I'm going to do this presentation about my startup project, the Pharo4IoT. And we are going to provide a solution to retrofitting legacy machines for the Industry 4.0. So, what is the Industry 4.0? In one way, you have the operation technology, is the technology used in the factories to create the equipment, to do all the operations, and the focus in this technology is in the operation and the production. And in the other way, you have the information technology, is the use of the computers to store, manipulate data, and to treat this data. And the Industry 4.0 is the combination of these two areas. You have the industry using the technologies from the information technology, like the artificial intelligence or machine learning. And in a big overview, we have the Industry 4.0, everything connected with the industry, connected in the cloud, in the users, in the machines, in the satellites, in the drone. This creates the Industry 4.0. But what this is not connected today? Because when the machines was created, they was created to just to operate without to stop and not to communicate with the information technology. So original the industry machines, they don't talk to the information technology. And in a report of Cisco, they say this more than 75% of the machines are more than 20 years old. And the 90% of the industrial machines, they still disconnected because it's expensive to exchange to the new ones, the return of investment is not interesting, and these machines are old but still working and they don't need to exchange it. So we don't have this link between the operation technology and the information technology. This link is broken. And in this way, the data analysis cannot be made. Like there's some players in the market offer services like process analysis to see how is the process in the industry, production optimization to improve the process of the industry, defect detection, and predictive maintenance to do a better use of the machines, but these are made with the machines already enabled to the 4.0 industry. And how to enable this legacy system, the old system, to transfer data to the industry 4.0 stakeholders, to this new, to these service providers, like the predictive maintenance providers. You can add a new layer of technology in these machines to retrofit these assets and equipment. We put some sensors in the machine, or we take the data from the PLC, is the logical controller in these machines, and we can do this retrofitting to enable and to take this data from the machine and stream to wherever you want. This open a new market share to the service providers. There is a good return of investment because you don't need to replace the machine. improve the factory process, and is ecological because you don't need to use a lot of resource to create new machines or to put the old one in the trash and just not be good to the environment. And how you are going to do this? You are going to provide one IoT platform. It's an industrial IoT platform. It's a solution in software and hardware to connect in these machines and extract the data, but do this retrofit in the machine, and use our platform to control this data, manipulate this data, and send this to wherever you want. And we are going to use the industrial protocols and like Profibus, Profinet, and Modbus, and use our hardware to take this, send it to our platform, and do this kind of manipulation of the data. And which technology we are going to use is the technology for Rmod Team. I had worked in India in Rmod for almost 3 years, and we are using this language. The name is Pharo. It's a live language. It's very good to see data in real time because you don't need to recompile the program every time we change something in the code, and you can change in real time, debugging remotely, and do everything in live. This is a very good language to this scenario, and I think this next step is to use this like a solution. I work specifically in the IoT field inside Rmod Team, and we have the Pharo consortium too. There's the industrial members. They are part of the consortium, where you can see the needs of these members and see how we can help and see how the market is going. And where we are positioned in the IoT value chain, we are taking the position as a platform, because we are going to be an industrial IoT platform, and specifically to enable the IoT capabilities and the integration with the third-party applications. And we can see this block, the platform area inside the value chain, there is a share of value between 30 and 40%, what is really interesting. And we are going to provide the solutions to companies, are going to do some data analysis, provide the services of data analysis to Industry 4.0. And I'm having meetings with the key people of this area. I had meetings, for instance, with the CEO of the Diagrams, and he explaining how the process works, and they don't have the technology to retrofit the old machine. So they work only with the industries is already prepared to the Industry 4.0. So we can target this sector, these companies as customers. This is assumption I'm did, and I need to search more and continue have these meetings to see how we can put exactly the solution inside the market. And we have here the industrial IoT market size global. The main one is the manufacturer, where there's these machines. The second is the energy and power, and the other is the oil and gas. And I'm going to explore these three markets. Where is the three markets there is more sense to use this kind of idea. And you have in the other way here the magic quadrant from the Gartner. Gartner is a company every year they release a report to see how is the performance of the companies, how is going. And we don't have leaders in the IoT platforms, in the industrial IoT platforms. We have niche players, and I think we have a good opportunity here, and I need to check more where to put our solution. And I'm the CEO of the Pharo4IoT. I worked for almost 3 years as research and development engineer in Rmod. And in Brazil, I have experience with entrepreneurship. I opened a company to do services to other companies in Brazil, and in the Rmod they are helping me with this. I have Marcus Denker is a research center. He is helping me to use the Pharo technology in a better way, and it's good because he has a company in Germany and he has this market vision. This is very important. And this tip is helped me to do this project and start with Startup Studio, and this is, I think this connection is being very interesting and very good. And I did these meetings with the key people from the company. I'm having the support from the STIP, the Rmod, and I'm contacting people in the LinkedIn, doing this market analysis and assumptions. And to the next 6 months, I'm in this process of the exploration. I'm going to exploration to explore the market, to validate the market, work in this business model, meet key people like in the Bobst. I have a meeting to this company with a key employee in this company. I'm going to validate the market with the Pharo consortium companies and develop a prototype according to the market's needs. So this was my presentation. Thank you for watching, and if you have some questions, let me know, please.
Thank you, Alex.
Welcome.
We move on to the question and answer session. Nicolas Landra.
I can start. I'm not sure I understand which part of the OSI level layers, which level of the OSI layers you're working on. Whether you're on the physical interface or the data capture. Do you have a slide that explains what you do and what you don't do? Or how do you interface with other parts of the OSI layers?
You mean in the hardware, with the hardware of the machines?
Starting from the hardware, what's available and what's not? What do you capture and what do you do with it? What kind of processing do you do locally?
Mm-hmm.
It's a complex process, you know. It's a complex chain, and that's why I'm referring to the OSI model, which is a bit old-fashioned. But those machines were designed when the OSI model was in place. As a matter of fact, thanks to INRIA.
Yeah, so in fact, we don't have the technology to industry. We are creating the technology for industry. And what I was doing, I was understanding how the industry works. Like we have the machines, and these machines is connected in the PLC, is a programming logical controller. And I saw you can connect in this PLC to take this data of this PLC. And the most of the machines in the industry, for the people I talk, they say is connected in the PLC. And we can also take the data from sensors, and you can retrofit in the machine, put sensors in it, and you can do a combination of this data of the PLC with sensors. Take this, we can put the board inside the industry and connect in this machine to retrieve this data and manipulate this data as you want, and to send it to wherever we want. Like we are going to provide this hardware and software to retrieve this data from the PLC or from the sensors in the machine. It was.
All right.
Mm-hmm.
Okay, understood. Thanks.
Sorry?
Yeah, I said thank you.
Oh, right.
Obrigado.
De nada.
I'm sorry, but I'm not sure I understood. So somehow to sell your product, you will need companies who sold the initial machines to add some components in order to give you data. Who is going to add the component that will extract the data?
So in fact, today in the machines we have the logical controllers, the PLC, to automate the machines. But this was not created original to stream the data. They have the data, they create the data, but it's just a local data. You cannot stream this. And with our solution, you are going to take this data of these logical controllers and manipulate this data to wherever you want. And we can put sensors too. Like we are not providers of sensors, but the client can buy a sensor and we can connect in the sensor to manipulate this data and send it to the data analysis service providers, for instance.
Because it seems to me that every kind of machine is going to be different.
Yeah.
That the analysis that you do for that machine is not the same. So is it going to be... I don't understand the model.
I see.
Is it going to be a specific work for each kind of machine that you're... I don't understand what you're doing, in fact.
So when you connect the machine, there's this point, like each machine is different. And this is why our technology is good to that, because you can see and explore the data in real time. Like, because in the compiled language, you need to write the program and compile the program and see if it's working or no. And with our technology, we can connect in the machine and see the data in real time and select what you want and what you don't want and easily manipulate this data. So this is a good differential using our technology, is this data exploring lively.
So your technology is some kind of easy to use language to deal with data.
Yes, we are going to use this language to manipulate this data easily.
Okay. But have you worked, so you have this technology?
Yes.
There is a lot of work to go to sell this technology for the purpose that you're giving us today. So what else have you done? I mean, is it just the technology that you have and the ID? I mean, the language that allows you to deal with the data and the ID to use it in this environment, or do you have more than that?
So we have as I say, we have the consortium. The consortium is already using Pharo technology. And what we are going to do now is use this Pharo technology in the IoT context, and is the industrial IoT context. We are working in this like for years. I work in the IoT Pharo project for almost 3 years, and we don't have a solution to the market exactly because it was not working in a solution. It was working developing the technology, and now this is the next step to take this technology and apply in the real world. And we are going to focus in this niche of sector to apply this technology was researched and created by INRIA and the Rmod Team. Thank you.
Thank you.
Sorry, I have maybe two small questions. The first one is what I understood is the pain point here is the subject is the interoperability within industrial context, where you have a lot of different machines, and then we need to have your hardware to get the data out of the machine, and then you have all your software and that will analyze all the data. And I was wondering what is the value proposition, the real pain point within the industrial within a project. Do you have a use case that in which we can understand the real value proposition? And the second question is, what are you doing with the data? Are you having something like predictive maintenance analysis, or do you plug to other software that will do the data analysis?
Okay. explain a case. Like I have a meeting with the CEO of the diagrams, and this diagrams company, they do predictive maintenance. And I asked him, how do you take this data from the machines? And he say, they only take the data with the machines is already streaming. And our position is to enable the legacy machines to stream this data to this kind of customer. These diagrams could be a customer of our platform. Like, we are not going to do the predictive maintenance, but we are going to enable these machines to stream the data to these customers. Okay?
Yeah, okay, it's clear for me. Thanks.
Welcome.
Thanks, Alex.
welcome.
The session ends.
Okay.
So, thank you for your presentation.
Okay, you're welcome.
Can you leave the video conference?
Yes, so thank you everyone, and have a nice day.
Bye-bye.
Bye-bye.